Hi class, I hope everybody's studying for their test and preparing well. Today in class, one of your classmates asked a homework question about surface area. Um, and the reason they asked the question is because the online assignment was doing something a little bit different than what we did in class, and I was trying to figure it out and was thinking on my drive home and finally figured out what they were doing. But I wanted to share it with everybody so in case you get stumped by that problem. I think, oh, I'm trying to remember what problem number it is. I think it was problem number 12 maybe. Anyhow, I'm going to show you a different way to find the surface area using one of the examples you already saw in class. This is from section 2.4, your class notes, and this is example 1, part C. We already did it, so you have it in your notes if you want to follow along. As you can see, we are trying to find the area that is or the surface area that's obtained by rotating y equals x squared from 1 to 2, 4 about the y-axis. This here is the radius of the little slice that we take, and because it's parallel to the x-axis, it equals 2x. And we know that in turn, x equals square root of y if we solve for x up here. Because of it, we did everything with respects to dy. There's an alternate way of doing this though, and I'm going to do it just below. So I'm going to write here alternate way. We're going to do the exact same problem. And I'm going to draw it I know you don't have to draw it, but just so we have a reference. Here's the x-axis, here's the y. We're rotating about the y, same picture. Y equals x squared. Okay. And then we're creating this, and I believe it actually goes from here. It doesn't go all the way to the origin. It goes there. Okay. And the reason I know it doesn't go all the way to the origin is because they tell us that the arc of the parabola is rotated from 1, 1 to 2, 4. Okay. Anyhow, we again take a little slice of it. Pardon my drawing. And again, I'm going to look at radius because remember, we're looking for the circumference of this one circle, this one slice, and the circumference is 2 pi r. So this is r, again, because we are parallel to the x-axis, r equals x. So far, I haven't done anything new. It's the exact same way we did the previous problem. But what I wanted to say is that r is equal to x, correct? Now, because x equals square root of y, which, again, we got from solving x in that equation, y equals x squared, we can actually use either one of these because they are equal. Since they are equal, it doesn't matter if I use x or square root of y. So let's suppose I do use square root of y to find the surface area. I'm sorry, not square root of. Let's say I use x to find the surface area. Again, one more time, just to reiterate, because these two are equal to each other, I can either use x or I can use square root of y as my radius, okay? So if I use x, that means everything has to be with respects to dx. So let's go ahead and write everything with respects to x. So now my lower and upper limit have to be with respects to x. So we no longer have y's. So instead of going from, from 1 to 4, we are now going from 1 to 2. Okay, those are my x values. And again, the radius that we're going to use is x instead of square root of y. Remember, these are equal, so I can use them interchangeably. And then, of course, the formula says that I multiply times the arc length, which is 1 plus f prime of x quantity squared dx. Now, I haven't found my derivative yet, but my function was y equals x squared. So let's just write f of x equals x squared, and f prime of x is equal to 2x. All right, so let's go ahead and plug in that derivative. So we have s equals 2 pi 1 to x square root of 1 plus 2x, which was my derivative squared dx. And I'm going to clean that up a little bit. We have 2 pi square root of 1 to 2 x square root of 1 plus 4x squared dx. Now, notice that we cannot simplify, but the derivative of one thing equals the other. Therefore, we are able to use u substitution. And I'm just going to give myself a little bit of room. I'm writing way too big. All right, so we're going to say let u equal to 4x squared. And sorry, I forgot the 1. Okay. Let u equal 1 plus 4x squared. Du is equal to 8x dx. And dx is equal to du over 8x. So we go back to the left side and we plug in our u. So we have x. And we have square root of u, but instead of writing square root of u, I'm just simply going to write u to the 1/2. And then dx, as we saw over here, is du over 8x. Okay, this is exactly what we want because the x's cancel. And we don't want any x's. We want everything in terms of u. So we have 2 pi. And if no one minds, I'm going to pull out that 8 in the denominator and write it outside. So now we have u to the 1/2 du. Again, I pulled out this 8 and wrote it out here. All right. Let's change our lower and upper limits to u's because right now they're in terms of x. So when x equals 1, u is equal to 1 plus 4 times 1 squared. And again, I'm getting that from here. All right, so we have u is equal to 1 plus 4, which is 5. And then if x is equal to 2, we have u equals, put a line so that we don't get confused. Okay, so 2 squared is 4. 4 times 4 is 16 plus 1 is 17. All right. So going back to the left side, we now have our u values. We're going from 5 to 17. And I'm also going to reduce this fraction. So that gives me pi over 4. And we're ready to take the integral. So we have u to the 3/2 times 2/3. And we're going again from 5 to 17. We're going to simplify this a little bit. And we get pi over 6. U to the 3/2. And we're going from 5 to 17. And we're ready to plug in our values. 17 to the 3/2 minus pi over 6. 5 to the 3/2. There isn't a lot of cleaning up to do. I am going to pull out one of the 17. So note that this is 17 to the 3rd power. There's 3 of them. So I can pull one out. And we get 17 pi. We still have one left. Over 6 minus, same thing with that 5 pi root 5 over 6. Not much we can do. We can leave it like this, or we can write it all under one denominator since they have the same denominator. And I just want to show you something. Look at this. This was my answer doing everything with respects to dy. Remember that? And look at this. This is my answer doing everything with respects to dx. So as you can see, it's actually the same answer. So again, any of these problems you can do using with respects to dx or with respects to dy. But I do want to say this. Sometimes one way is easier than the other. For example, actually, why don't we look at part A? Example 1, part A, if you want to refer to your notes, that was f of x is equal to 2 root x. And this time, we are rotating about the x-axis. Okay. Oops. Sometimes my Apple Pen doesn't want to cooperate. Okay, so if we do this and we rotate and we take a little slice, okay, this here now becomes the radius of this slice. Now the radius is parallel to the y-axis, so the radius is equal to y. What does that mean? That means that if I write a formula for surface area, I can do two things. I can do 2 pi from, let's just call it CD, okay, of y, right? Because again, these are interchangeable. So I could actually write y. If I write y, then everything is going to be in terms of y. Square root of 1 plus g prime of y, whatever my function is. But everything has to be in terms of dy. Or I can use the left-hand side. Again, these two are equal. So we can either use just y or we can use 2 root x. So if I use 2 root x, guess what? Everything has to be in terms of x. So I have 2 root x times the arc length, which is 1 plus f prime of x quantity squared dx. And these guys here, these limits are in terms of y. And these are a to b. These are in terms of x. I'm not going to do this one in terms of x, but I just want you to see that both of these problems are going to give you the same answer, the same exact answer. And that is it. I hope that I clarified some things, and there really was only one problem on the homework that they changed. They changed their radius to just y or x. I can't remember what it was. My point is that, again, because these are equal, you can either use one or the other. And it's good to know that because there are times when it's easier to use y and there are times when it's easier to use the right side of the function. Well, that is all for now. Please don't hesitate to email me if you have any questions. I will be better at checking my email this weekend because I know that we have an exam. And I hope everybody has a good night, and I hope that helped. See you on Monday.